Hello, my dear students. Myself, Professor Fauti PV, Senior Lecturer in Physics, Jain Polytechnic, Puranjunnar. Here we are learning Part 4 Dimensions of Physical Quantities from Chapter 1 Units and Measurements from Basic Physics. So, earlier we have seen various types of units: fundamental, derived, and supplementary. Fundamental, as the name indicates, such type of units does not depend on any other unit for its measurement. For example, unit of length meter, unit of mass kilogram, unit of time second, etc. Whereas derived units, these are obtained from the fundamental units. For example, unit of area, it is meter square. Area, we can write area as length into breadth. So meter into meter, so it is meter square. So meter square is a derived unit which is obtained from unit meter of length. So while deriving these units, power of meter, it is raised to 2. So this power here we write it, called it as dimensions of physical quantity. So generally we define dimensions as the powers to which the fundamental units are raised. To obtain the unit of a physical quantity, these are called as dimensions. Another example, we can say unit of velocity, it is meter per second. So this unit, it depends on two units, meter and second. So as we have obtained these units, it depends on meter and second, two fundamental units. So their powers are raised to, for meter it is raised to 1, for second it is raised to -1. So these are called as dimensions of these physical quantities. From dimensions we can have dimensional formula, which is just an equation giving the relation between fundamental units and derived units in terms of dimensions. So as we know that there are 7 fundamental quantities. So all the derived units, this depends on these 7 basic quantities. So dimensions gives how these various units, these are related with 7 fundamental units. So let us see how dimensions are obtained. There are certain rules for dimensions of physical quantities. The first rule is that all the dimensions are always written in square brackets. The second important rule, while obtaining dimensions of any physical quantity, we take capital L for length, capital M for mass, capital T for time. These are just the symbols or capital letters. If any of the fundamental quantity does not occur in any physical quantity, then its unit is raised to power 0. If any fundamental unit it is absent, its power is raised to 0. In sometimes the units are at denominator. So units at denominator, these are shifted to numerator, but while shifting to numerator, its power is assigned negative sign. So these are certain 4 rules for deriving dimensions of physical quantities. And now with the help of these rules, we will derive, or we can have certain examples on dimensions of various physical quantity. Let us first see the dimensions of length. In quantity length, we have only one length quantity, or length 1 times, mass quantity is absent, time quantity is absent. The quantity which is absent, its power is raised to 0. So only length quantity is there. So dimensions of length, it is L raised to 1, M raised to 0, T raised to 0. Similarly, dimensions for mass, here mass quantity is present, so M raised to 1. Length and time quantities are absent, so their power is 0. So dimensions of mass, it is L raised to 0, M raised to 1, T raised to 0. Dimensions of time, so time raised to 1, time quantity is 1 time, so T raised to 1. Length and mass quantities are absent, so their powers is 0. So dimension of time, it is L raised to 0, M raised to 0, T raised to 1. Now we will obtain dimensions of area. You know that area, it is length into breadth, so it is meter square. So quantity of time, quantity of length, meter, it is 2 times, so its power is raised to 2. Mass and time quantities are absent, so their powers are raised to 0. So we can say that dimensions of area are L raised to 2, M raised to 0, T raised to 0. Similarly, we can write dimensions for volume using formula length into breadth into height. So its unit is meter cube. So dimensions of volume, these are L raised to 3, M raised to 0, T raised to 0. Now let us have dimensions of speed or velocity. We know that speed or velocity, it is given by formula distance upon time. So its unit is meter per second. Second unit, it is at denominator, so it is shifted to numerator, but while shifting it is assigned minus sign to it. So meter per second, this unit can be written as meter second raised to minus 1. So we can write dimensions for velocity or speed as L raised to 1, m raised to 0, t raised to minus 1. Meter in this case, it is for length, not mass. This, remember this one. So L raised to 1, mass quantity is absent, so it is m raised to 0. Time quantity at the denominator, it is shifted to numerator, so t raised to minus 1. Similarly, we can find out dimensions for acceleration. We know that acceleration, it is velocity upon time. Instead of velocity, we write distance upon time. So this can be further simplified as distance upon time square. So unit of acceleration, it will be meter per second square, which can be written as meter second raised to minus 2. So dimensions of acceleration, it becomes L raised to 1, m raised to 0, t raised to minus 2. Let us have dimensions of density. Density, it is given by formula mass upon volume. Unit for mass, it is kilogram. Volume measured in meter cube, so its unit is kilogram per meter cube, or it can be written as kilogram meter raised to minus 3. So dimensions of density, it can be written as, so kilogram, it is for mass, meter, it is for length, quantity of time is absent, so its power is 0. So we can write L raised to minus 3, m raised to 1, t raised to 0. Similarly, we can find out dimensions of force. By Newton's second law of motion, force, it is given by mass into acceleration. So we can write its unit as, for mass we write kilogram, for acceleration we write meter per second square, or same unit can be written as kilogram meter second raised to minus 2. So dimensions of force, it becomes L raised to 1, m raised to 1, t raised to minus 2. Let us have another example for pressure given by force upon area. Force, already we have seen, it is mass into acceleration. Area as it is, so it can have the units. For mass we write kilogram, for acceleration meter per second square, for area we have written meter square. Simplifying it, we can write kilogram per second square upon meter. Again, further simplifying it, we can write it as kilogram second raised to minus 2, meter raised to minus 1. All the quantities at denominator, these are shifted to numerator by assigning negative sign or minus sign to it. So finally, dimensions of pressure, it becomes L raised to minus 1, m raised to 1, t raised to minus 2. Remember, meter, it is for length, not for capital M. Capital M denotes mass, so its unit should be kilogram. Let us have the dimensions of momentum. Momentum is written as mass into velocity, so its unit is kilogram meter per second, which can be written as kilogram meter second raised to minus 1. So dimensions of momentum, it becomes L raised to 1, m raised to 1, and t raised to minus 1. Let us have the dimensions of work. Work is nothing but force into displacement. So force, it is mass into acceleration. So displacement, it is nothing but distance. So you can write now the units of all these quantities: mass in kilogram, acceleration in meter per second square, distance in meter. Simplifying it, we can write kilogram meter square second raised to minus 2. So dimensions of work, it becomes now L raised to 2, m raised to 1, t raised to minus 2. Similarly, we can find out dimensions of power. Power given by formula work upon time. So its unit kilogram meter square second raised to minus 3. As already we have obtained the unit for work in above example. So dimensions of power, it becomes L raised to 2, m raised to 1, t raised to minus 3. Let us have dimensions of frequency. Frequency, it is a quantity related with oscillations or rotations. Frequency is number of oscillations in 1 second. We can write it as 1 upon second or second raised to minus 1. So dimensions of frequency, it becomes L raised to 0, m raised to 0, t raised to minus 1. So now we can summarize all these physical quantities with their dimensional formula, starting from length measured in meter. So it's L raised to 1, mass measured in kilogram, so m raised to 1, time or time period measured in second, so its dimensions t raised to 1, area meter square, so its dimensions L raised to 2, volume meter cube, so its dimension is L raised to 3, speed or velocity measured in units meter per second, So its dimensions are L raised to 1, T raised to minus 1. Acceleration measured in meter per second square. So its dimensions are L raised to 1, T raised to minus 2. Similarly, all other physical quantities with their units and dimensional formula, these are tabulated here. Now we can have MCQs related with these dimensions of physical quantities. The first MCQ, the dimensions of a physical quantity are the dash dash to which fundamental units must be dash dash to obtain the unit of a given physical quantity. So this MCQ it is obtained from the definitions of dimensions of physical quantity. So we can say the dimensions of a physical quantity are the powers to which the fundamental units must be raised to obtain the unit of a given quantity. So correct option here it will be option C. Second, to decide dimensions of a physical quantity, the unit of time is expressed by. Now unit of time it is second. So already students get confused with, they gave answer option A as S. But while obtaining dimensions, we write symbol capital T for time. So in this case, option D, capital T, it is the correct one. Dimensional formula for area. So dimensional formula for area, it is option A, L raised to 2. We can simply write L raised to 2. Both powers of mass and time are 0, so its power it is raised to 0. Dimensional formula for density. We know that density it has unit kilogram per meter cube. Per meter cube, so it is L raised to minus 3. For mass or kilogram, it is m raised to 1. So option B it is correct one, L raised to minus 3, m raised to 1, T raised to 0. In the dimensional formula, L raised to A, m raised to B, T raised to C, A, B, C are called as. So A, B, C, these are the powers, we called it as the dimensions of that physical quantity. So option B is correct. L raised to 1, m raised to 0, T raised to minus 1 are the dimensions of. L it is for length, so we write meter. T raised to minus 1 it is for time, so we write second raised to minus 1. So meter second raised to minus 1 or meter per second, these are the units for speed. So these are the dimensions for speed. Dimensions of dash dash and dash dash are same. We know that work and force, these are different quantities. Velocity and acceleration, these are also different quantities. Length and mass, these are also different quantities. But pressure and stress are same quantities. So dimensions of pressure and stress, both are same. It is if L raised to A, m raised to B, T raised to C are the dimensions of force, then find the value of 2A minus C. So dimensions of force are given in terms of ABC, and we have to find out the given relation. So we know that dimensions of force, these are L raised to 1, m raised to 1, T raised to minus 2. Comparing both the sides, we can say that A is equal to 1, B is equal to 1, C is equal to minus 2. Now we can find out the value of 2A minus B minus C. Substitute the value of A, B, C in this case, and finally we get option correct answer as 3. So option C, answer 3 is correct one here. L raised to 1, m raised to 1, T raised to minus 2 are the dimensions of. So these are the dimensions of force. Option C. Dimensions of dash dash and dash dash are not same. Here speed and velocity both are same quantities. Pressure and stress, these are also the same quantities. Work and energy also are same quantities. But force and energy, these are different quantities. So dimensions of force and energy are not same. So option C, it is the correct answer here. Thank you very much. If you like my video, you can like and subscribe my YouTube channel. Thank you very much.